My name is George Gonzalez from Group 5, and today we're going to be doing question number 5 and question number 15. Question number 5 states that a charge Q equal to 2 microcoulombs is placed at the origin in a region where there is already a uniform electric field equal to 100 N over C. Calculate the flux of the net electric field through a Gaussian sphere of radius r equals 10 centimeters centered at the origin. And it's also given that epsilon is equal to 8.85 times 10 to the power of negative 12. But we already know that. So for this equation, for this problem, what we're going to want to use is Gauss's law. And Gauss's law states that the electric flux is equal to the total charge divided by the electric constant right there. So here we're given that Q is equal to 2 microcoulombs. So we're going to write that in regular coulombs without the micro. So we're going to add times 10 to the power of negative 6. And coulombs right there. And then we're going to divide that by the electric constant, which is 8.85 times 10 to the power of negative 12 coulombs squared and times m squared. So when you put this into a calculator, you go on and you get 2.26 times 10 to the power of 5, and then the units sort out to be nm squared over coulombs. So that right there is the electric flux of the net electric field through a Gaussian sphere. So now for question 15. Question 15 states that 2 extremely large non-conducting horizontal sheets each carry uniform charge density on the surfaces facing each other. The upper sheet carries plus 5 microcoulombs over meter squared, or m squared. The electric field midway between the sheets is 4.25 times 10 to the power of 5, pointing downwards. What is the surface charge density of the lower sheet? So for this question, we're going to be looking for the lower sheet, for the surface charge density of the lower sheet, which is typically represented as sigma sub 2. And an equation that we know that we can work this into goes like this. We start with E equals E sub 1 minus E sub 2. And then we can substitute in the E's, sigma sub 1 over 2 times the electric constant minus sigma sub 2 over, again, 2 times the electric constant. Now, if we keep on rewriting this, we can put these together. So it's sigma sub 1 minus sigma sub 2 all over 2 times the electric constant. So then we can multiply over 2 times the electric constant. So we can get E times 2 times the electric constant, which would just be equal to sigma sub 1 minus sigma sub 2. And from here, it's pretty simple what you need to do. You can just add a sigma sub 2 over and subtract this over onto the right side. So there you get sigma sub 2 is equal to sigma sub 1 minus 2 times the electric constant times E. So now that we have an equation that directly is equal to sigma sub 2, we need to find out the value of these variables right here. So if we refer back to the question, you can see that the upper sheet carries a charge of +5, and the electric field midway between the sheets is 4.25. And right here, it's also given that the electric constant again is 8.85 times 10 to the power of -12. So we can say that sigma sub 1 is right here, +5. And the value of E is right here, 4.25 times 10 to the power of 5. And then again, electric constant right there, 8.85 times 10 to the power of -12. And that would basically cover each of these variables that we have right here. So with sigma sub 1 being +5.0 microcoulombs per m squared, the electric constant being 8.85 times 10 to the power of -12 and then with E being equal to 4.25 times 10 to the power of 5 over C. All that we have to do is plug them into this equation right here. So sigma sub 2 is equal to, we're going to put these in parentheses, equal to 5.0. And we'll put the units at the end. 5.0. And then we're going to add this right here to change it from micro back to the standard unit of Coulomb. So that right there is sigma sub 1, the value of it. And then all of this right here is minus 2. Let me actually write this down here. Minus 2. Then the electric constant. Times the electric constant times E, which is 4.25 times 10 to the power of 5. Sum this all up and multiply the rest of these, and you get that sigma sub 2 is equal to -2.52 times 10 to the power of -6. Or well, actually, That's 2.52 because right here we got rid of that -6. So it is equal to 2.52, -2.52. And the units are coulombs per meters cubed. And that right there is the answer to question number 15.